In this video, I'm going to do a brief Matlab introduction and maybe a small tutorial as well for that goes along with our course. Okay, so this is Matlab, and what Matlab has is basically a command window, and here in the command window, I can write the commands one command after another. I can write, for example, A is equal to 1. I can write B is equal to 2, and then I can do, for example, A plus B, and then it will give me the value. So this is like a calculator, basically. You can think of it that way. I could do like, sine of any values, right? So I can do, and this is in radians, so I could do like, sine power 2 or cosine of power 2, and then it will simply do it. Okay. I can basically do vectors, and I can write an array, for example, like 1, 2, 3, 4, right? I can multiply this array by, whatever function. I can multiply it by 2. So this here computation is basically parallelized. I can do like cosine t basically, and it will do the cosine of every value in that. All right, so in terms of what we want into our course, basically we are interested in being able to do array multiplication in Matlab based on what we have here. So this is a rotational transformation, and I would like to be able to do this array multiplication directly on Matlab. So for us to be able to do this, we have to basically define functions. So I already had a function here, but I'm going to actually rewrite a new function. So the way for you to write a function is basically you just add a new script, and I'm going to define a function. So I'll just simply call function. Right, and then this is the output of the function, and now I'm gonna write the name of the function. So here, the name of the function, I'm gonna call it ROTX, and here it's gonna take an argument basically, and that is a function basically. So theta is the input of the function, and then A is the output. So I can basically write here A is equal to 2 times theta, right? And then basically now I'm done with the function. However, that will not work. And by the way, if you put a semicolon, basically you just suppress the output. Essentially, you suppress this value from basically showing on your command window. So for the function to basically be done, basically you have to save it as a function name. So the function name is ROTX, or rotational about x-axis. I'm going to save it. So now it's going to actually show up in my workspace. Okay, for me to be able to use that function, I'm going to actually have to call it from my command window or from a separate script. So I can do like ROTX of 1, and then basically it just did that function, right? ROTX. So basically it's multiplying 1 by 2. Okay. What I'm going to do right now is basically the output could also be an array, right? So a rotational transformation basically about x-axis is equal to what? 1, 0, 0, 0, and here what I'm doing is basically I'm simply copying this guy, right? 1, 0, 0, 0 cosine x minus sine theta x. So that is 0 cosine theta, right? Minus sine theta, and then 0. And then 0 sine theta, cosine theta, and then 0, 0, 0, 0, and then 1, and then there we go. So now basically we have our rotational transformation. I'm going to save this, so you always have to save it. Now let's look into what is the rotation of x of 1. So basically, it basically did the array, right? Okay, so in Matlab, basically, if I ever want to clear the command window, which is this guy, command window, I'm going to do it by CLC. I still have variables stored here, right? And then the type of the variables, I can basically clear the workspace by typing click vars. If I do click vars, basically, I'm going to clear the variables. So now if I actually do rotation of x like that, basically, it says I don't have enough input arguments because the rotational matrix is a function of the variable theta, right? So I can basically now define theta symbolically as a symbolic variable by doing this. So I can define basically as many variables as I want simply by doing that, right? So, theta 1, theta 2, etc. So now basically I have defined theta 1. One of them is, so basically theta 1 appeared twice, so nothing's going to happen to it. So now if I actually type theta 1, basically it's a symbolic variable, right? And I can pass this into the rotational transformation. So I can do rotation of x of theta 1. Okay, theta 1. And what happens basically is that you go. So basically you actually have that rotational transformation. Okay, now let's actually add one more function. Let's add rotation about the y-axis. So I'm gonna do a new script, and let's do this. So function, right? A, oops. So A is equal to rotation about the y-axis, and then this is also gonna take theta, and then I'm gonna end it here. And then what would be A, right? So that would be cosine theta 0 sine theta 0 0 1 0 0 minus sine theta 0 cosine theta and then 0. Oops, that would be 0 and then 0 0 0 and then the last value is 1, and then I'm going to suppress the output with the semicolon. Now I'm going to save that. So you want to make sure now it's untitled 4. I'm going to have to save it as rotation about y. Okay, and then it's an numpy. So when I did that, basically it automatically, notice Matlab automatically detects the type of the script, and if it's a function, basically you will basically see on it f of x. So let's do rotation of y, right, about that 1, right, and then I have rotation of x about that 2. Right? So now basically I have these two. I can now do basic rotation about x times rotation about y. No, we have to put the argument, right? So you have to pass an argument, theta 1 times rotation y of theta 2. And here you go. Basically, let's actually call A is equal to the answered. So now we can simplify that. A is equal to TLC, A. So basically now this is my A. Now here my output is that. I can try and actually simplify A if I can. This is the most simplified version. Okay, so this is basically rotation about x and then rotation about y, and then this is what you have, what you basically end up with. I can basically put this whole thing into. So I was doing all my commands in my command window. I can actually write a script, and then when I run the script, it will basically execute all these functions. In our course, basically, whenever that you have to basically have a script, so you want to just kind of put your name. You know, if you were working on an assignment, basically it would be like, for example, assignment 1. And let's say you want to, for example, do a rotational transformation. I can call, like, you know, RO1, for example, right? RO1 is equal to rotational transformation about x-axis by a value theta. But here theta is not defined, so I'm going to have to define since theta 1, for example. Right, and then I can do R12, for example, is equal rotation about y by theta 2, right? And then I can do like R02 is equal to rotation about x, or basically now that I have that, I can simply do R01 times R12. Okay, so I can run that basically, tutorial, let's call that tutorial. Now I'm gonna run it basically, and obviously when I run that, basically there's something already on the command window. So what you want to do is when you start your script, you want to clear the command window, you want to clear the variables, and then you can actually click do CLF, basically it will clear the figures. Okay, so let's run that basically. So we have an error. What is the error? Undefined theta 2. Okay, so we didn't define theta 2, so let's define theta 2 as a symbolic variable. There you go. So you can basically see how you can use Matlab in a very fast and efficient way of actually doing things here.